John, I can't remember.
This is Derek.
Derek, that's right.
Derek
sorry.
Richall.
Derek Richall.
Yes.
R-I-C-H-E-L-L. E-L-L, right, okay. And you're over from the States.
From California, yes.
Yeah, okay. And you worked at Elliott's?
Yes, I was at Elliott's for 2 years, worked in the research department for Ed Hersom.
Oh, yes,
and,
yes.
Who I lost track of.
Right, well, I think we still got him, I think we've got his record. I've got a whole load of records here I can go through with you.
Oh, good.
Of the people that were at Elliott's.
And the other gentleman I can remember, his name's Williams.
Yeah.
I don't remember his first name, which is awful. I'd like to contact him.
Yeah.
And I have kept pretty good contact with Elliott's through Bob Hamilton, who did eventually come over to the United States too. But he was the programmer of the other side, the commercial side. So. Yeah, in fact, I got to Elliott's through Jerry Mills, who was, really handled the marketing side of Elliott's work.
Yeah. That's nice. It all comes to an end. Which is rather sad after 4 years.
Yes,
but the Science Museum has just decided their priorities are elsewhere, and what can we do?
Now, what about the other activity that goes on? I was good contacts at ICL, and they've been doing some archiving stuff at Manchester.
Yes, that's right.
Any tie-in there at all?
Yes, we shall, that will carry on. It just means that the work centred here at the museum will stop, but the Conservation Society will keep going. Because I started the Conservation Society when I came here to the Science Museum 4 years ago, and I'm secretary of that, and I'll take that with me home and run that from there.
Now, what about the facilities here, though, and equipment?
Well. That's the problem, that they want this space. Somebody else wants this space in the museum, the usual problem. And so we've got to get out. So it means that the computers will have to go to another storeroom somewhere. And we're trying to make certain that they're at least kept alive and running rather than being just killed off.
Yes.
It would be a great pity, having spent all this time getting them working and getting them going. The Pegasus we got working there is probably the oldest working valve computer in the world at the moment.
Really?
Yeah.
That's interesting.
And of course, if we get the Elliott 401 working, then that'll easily blow that record, because that's 6 years younger than Pegasus.
Yes.
Certainly we've established a world lead in the technique of restoring computers.
That's great.
You say you worked on Nicholas. Was this as a programmer, or was this a...
No, well, kind of.
Yeah.
I was, as I say, in a research department, and we were working on an all-solid-state computer for control purposes. Actually, it was for a...
Was this the 152?
No, it wasn't. It was Nicholas. Oh, well, no, I don't think it was anything.
Yeah.
I believe it had a number.
Right.
But it was a magnetic logic element using Ramey circuits.
Yes.
And germanium diodes.
Yes.
And a sine wave power generator, which was the clock signal.
Yeah.
So it was all solid state, and it was for control purposes. And
right.
It was for really the start up and shut down sequencing of an atomic power.
Oh, I see. Right.
Somewhere down in Portsmouth,
yeah.
which was I guess a prototype for a proposed submarine nuclear power.
Right.
I don't believe that ever got to anything. I don't really know. But anyway, that was my project. That was I succeeded in that over a 2-year period.
Right.
And that's the point that I left Elliott's to go and discover all the great things that go on the other side of the water.
Yes. Yeah. Right.
So Nicholas was used in some of our work as an incidental activity.
Yeah. Right. As a tool. Yeah.
Well. Yeah, and Williams was one of the programmers out there, and he helped on the programming of the control computer that I built.
Right. Yes.
Under Ed Hersom.
Yeah.
So,
okay. So, so what this was about? About 1957 or thereabout?
57,
58. Yeah.
Maybe the beginning of 59. Yeah.
Okay. Right.
So that's.
Yes. So yes,
so I really wasn't around during when Nicholas was conceived, and it was actually fully operating. It was still being used from time to time, but obviously that wasn't a main.
No.
It was an oddity sitting over on the side.
Yeah, right. Yes.
Next to Eccles, which
yes.
was, I think, really the earliest computer they put together. It was still an in-house development computer. If I remember, Eccles stood for.
I'd never heard the name Eccles before.
ECCLES. Yeah. Electronic computer consisting of lots of excess supplies. That's what it was. So
I see.
That Eccles came after Nicholas.
Yes.
And it was the precursor to the 401.
I see. Oh, that's interesting.
It was literally wires hanging out like a rack.
Yes, a lasher. Yes. Yeah.
So,
okay.
But it was a fully working computer.
Was it?
Yeah.
Oh, let's find out more about it.
I'm pretty sure it had a disk. And that, as I say, that disk, I believe the biggest problem with that was the stretch. When it was spun up, it would stretch, and all the tracks on the outer edges would move.
Yes.
Which meant you lost signal.
Yeah.
No, in fact, my fondest memory of the Nicholas is the big problem it had was with the annealing, work hardening of the ends of the nickel wires. You get reflections. So you have to have a box of matches to re-anneal the computer, watch on the scope until you got it correctly annealed. And
I see.
The signal got better, and off you went. Continued to run your program. So that was the repair kit.
That's an amazing story. Yes.
So you didn't know?
No, I haven't heard that one.
The other nickels, the nickel delay lines, they don't get work hardened?
No, they don't. No.
It was probably very pure nickel rather than nickel alloy.
Yeah. And, well, the later ones were the earlier ones were nickel, but the later ones, which are in Pegasus, are the torsional mode vibration lines.
Okay. No,
and that was Gordon Scarrett produced that, and they of course are steel piano wire with just the nickel wires welded across a diameter at the end to differentially push and pull the torsion mode into the line.
Okay, well these were obviously longitudinal.
Yeah, they're just straightforward longitudinal ones, yes. But what they found, well, you probably remember, was the dispersion was pretty awful on that. So the pulse shape was pretty rough when it came out the far end.
Yes, well, especially if you got echoes off the end.
Yeah, that's right, yes.
It would kill the signal very nicely. So.
Yes. So your annealing was to get the impedance right at the end, so the acoustic impedance.
There, and we could unwork harden the end. Get it nicely annealed and get it nice and soft again. Then it would.
Was it self-work hardening then because of the acoustic pulses?
Yes.
Yes, I see.
Oh yes.
Oh, that's interesting.
Now why it was at the ends, maybe it worked hardened all the way around. It's just that the impact on the signal was very, very bad at the ends.
Sure.
So, So I suspect the whole line, the whole nickel line was like that. Yeah. So there, again, it wasn't that interesting to us. Nicholas was just an oddity, so people who actually did the work didn't really talk about it that much. But I do remember being told that it was put together. I believe Ed Hersom was very instrumental in that.
Yeah.
For the Decca navigation calculations.
Yes, it was specifically done for calculations. I do know that. Yes.
Yes. Yeah, they had a contract, and I believe Ed was brought in from Cambridge to do that, and I think the job had been bid on the basis of having something like 24, 48 people sitting with desk calculators for, I believe it was 2 years. And if anybody made an error during the beginning of that cycle,
you had to go right back.
Well, I don't know whether they probably would detect it eventually, and then that all would be wasted. So the story goes, and it's just a story, that Ed convinced them that from his experience at Cambridge, working on a computer over there, that they could build EDSAC, right?
Yes.
They could build a computer or program it and get the results in less time than
the manual method.
The manual method, and that in fact is what happened. So.
Yes, Andrews and Johnston, I think, told me that there were only something like 80 valves in it. It was or 80 gates, did he say? I'm not sure, but it was a pretty sparse machine.
Oh yes, yes, very sparse. Very simple command structure, very simple, but effective. I mean, it did what you want to do. And very good for those linear equation type solutions, because it was just pumping through a lot of numbers.
Yeah. Well, because electronics is my background, my blood, so to speak, and valves and so on, I'm very keen, while it's still possible to build replicas of these machines while people are still around who can actually give me all the details, and while the components are still around. Particularly the Manchester prototype, the one that ran the first stored program in 21st June 1948.
Yes.
That only had 250 valves in, so that's a relatively simple one to do, and that's one I'd like to have a go at. But certainly Nicholas struck me as one being eminently possible to reproduce, because it seems to have a very simple logic to it, a very simple structure.
Yes. And so, who have you been able to contact?
Well, let me go and look at my list of names. Just a second.
Well, it had 110 tubes in it. That was its claim to fame.
Oh, right. Yes, yes, yes. So where was this? This was where you went to in the States?
Yes.
Where was that?
Well, I was in Toronto to start with.
Oh, right, okay, yeah.
And they moved me down to Atlanta and then to California.
Right.
That was the end of my travels.
Yeah, okay.
This is wonderful to see this.
Yes. And this is George Felton's programming book.
Yes.
George Felton's still around and comes
is
around.
He?
Everything. Oh, yes, yes, yes. Yes.
I don't remember him at all.
Yeah. Yes.
But I remember the book. That's really good.
Yeah.
Okay.
I'll do a copy of the other bit for you about Nicholas.
Yeah,
sure.
Yeah.
Yeah.
So,
Yes, I think that's all I've got on Nicholas. Is that one article.
well, that's more than I've got.
Yes. Yes.
It's great.
But yeah.
I would really like to try and contact Ed Hurson.
Yeah.